All right, so the next quick thing to talk about is lerping keyframes. Now, we've already done this kind of, but I want to go in this specifically because in the examples so far, all that we do is we go between A and B, A and B, A and B. But in my examples earlier, I said we have A, B, C, D. We can do all kinds of things. So if we want to go from just having A and B to a whole list of keyframes, our existing code works pretty much out of the box, okay? But to upgrade to more general keyframes, all that we have to do is add a little bit of management. It just requires management of A and B, where A is our start and B is our end. Another way to look at it is our A is our t equals 0, and the B it was where our t equals 1. So we have to manage that start and end positions of our keyframes. So imagine now we have A, B, C. These are our keyframes, and we want to go from A to B to C to D. Previously, we just have a little a, little b, our start and our end point. We just do something like this. Okay, our current started at A. I'm gonna make a little side note here. This was our A from before. This is our A to B. And then we can also have another variable called our next. We set it to B. And same thing, this is our little b from our previous interpolation example. And then where am I? Yeah. Then if reached next, and it's really easy to figure out, t is bigger than or equal to 1. If we reach that point, then we go, okay, now our current one is B. That's our new starting spot. And our new next point is C. So you just move along the keyframes like that. So it's really, really simple. Let me just draw out what this might look like. So if I have A here and I'm interpolating along, I should draw a straight line. Here's B and here's C. The first time we go over, we go, okay, t is 0, right? And then we interpolate along with however many steps we want, and then we get t of 1. Uh-oh, we've reached our end point. We have to reconfigure and start over again with t is 0 here, and then t until we reach t of 1 and interpolate over to C. So if we have our A to B code working, we just modify where A and B are pointing to, and we can get our keyframes to work. What else am I going to add here? Yes, when we reach next t, we should set our t to 0 to start over that interpolation. So I'm going to show a demo. It's really nice, easy, and really scales well. So here's pretty much the same code we've been working with, except now, instead of having A and B in these float arrays, I have this two-dimensional array that I call keyframes. And each one of these is going to be an x, a y, and a theta, right? X, a y, and a location. So instead of just A and B, I now have A, B, C, D, and E. So I have 1, 2, 3, 4, 5 keyframes that I'm using in my code. I have a new variable called current keyframe, which I set to 0. I start at the first one, and you increment that along to remember where you are. That's all that you do. I just have a recalc. This is just a flag to tell it to recalculate the distance, and how fast how many steps. So that's just a little bit of management. You can look at the code later. It's not a big deal. So then, at the beginning of the program, we're at keyframe 0. Instead of working on our arrays A and B, now I have my current. My current is, well, the keyframes array, the current keyframe. The next one is, well, +1 mod length, so it loops around, okay. And then it recalculates, if I need to recalculate it, recalculates how fast it should move. And then I'm done. That's all I have to do. That's all I have to do. And I calculate my t as normal. I interpolate my x and my y using my current to next instead of A and B. And my theta is the same. Then I'm done. The only other thing we have to do is, as I'm increasing my step along, I figure out whether I'm at my t of 1. In this case, it's my steps, not my t. I'm at the end. All right. If I'm at the end, I advance the keyframe to 1 and loop around. So I go on to the next keyframe. So when the cube hits the end of the steps, go on to the next keyframe. The one thing I'll mention here, I'll actually change this. Some people often go, if it's bigger than steps, let's do that. And you'll see a problem. So let's run this. There's no interaction now. The mouse is turned off. It's going to go from first keyframe to the second one. And then as soon as it gets there, it'll bounce to the next frame, right? Just like that. Now you might not have caught it. Let's see if I can start it over. Watch at this point here. When it goes to the next keyframe, does it maintain perfect speed? Look at that. How smooth is that? Huh. I must have changed my code because last time you could see a definite stop there. Let's see. So now it's a different off by 1. I was noticing a definite stop there. No, it looks smooth now. Maybe I missed it. But this is the off by 1 with keyframes I've mentioned before, where you don't want to double up that last keyframe. This looks fine. Yeah. It's the nice thing about these things, they can be pretty forgiving. Oops, I dropped my pen. But if you notice it being a bit at that end point, it doesn't smoothly go, watch that off by 1 error. But this is nice. We're going from keyframe to keyframe to keyframe, and you can imagine if you have a game set up or an assignment and you want something complicated to happen, you just set up the keyframes and you set up this interpolation system, and you can have some really advanced stuff happening, a lot of things moving around, and all that you have to do is solve that local problem, okay? That local problem of setting up the keyframes and interpolating using Lerp. So it's really quite nice. All right, so that's all I'm really going to say about keyframes. We're going to come back and learn a more complicated way of lerping, or to give you more freedom over how it looks and acts. But for now, this is basically it. This is lerping.